Hello everyone! In this video, we'll tackle about the Dalton's atomic theory, the earliest Rutherford nuclear model, and the organization of the table of elements. Before we start, let me introduce myself. I'm Rowana Pico-Bactulan, a student of Bachelor and Secondary Education, major in Science. By the way, who is Dalton? Dalton's theory, known for his work on developmental atomic theory. Dalton began a series of experiments which would culminate him in proposing the atomic theory of composition. In 1803, after years of researching, Dalton wrote his atomic theory. According to Dalton theory, all matter, whether its elements, a compounds, or a mixtures, is composed of small particles called atoms. In Dalton's theory, there are 6 postulates. So, here are the first postulates of Dalton's atomic theory. First is, all matter consists of indivisible particles called atoms. As you can see in this picture, there are gold element and a carbon element. In that circle, you can see the yellow that is a gold that is called the atoms, and the black circle is called the carbon atoms. Example, this gold and carbon, these are the matters. It's made up of small particles, and that tiny particles is nothing but the atoms. And every atoms of every matter participated in a chemical reaction. Second postulate of Dalton's atomic theory is atoms cannot be created or destroyed. In this chemical reaction, as you see in the picture as an example, there are the chemical reaction of one oxygen atom reacted with 2 hydrogen atom if formation of water molecules. In this reaction, there is no destroy and no loss of any atoms. That's why we cannot create as well as we cannot destroy any atoms. Third postulates of Dalton's atomic theory. Atoms of a given element are identical in mass and chemical property. As what you can see in this picture, this is a green color, green color atoms. All atoms of the same elements, these are atoms of the same elements, means all atoms are identical in mass, the chemical properties also. The green atoms are having the same mass as well as the same chemical properties. The purple atom is the different chemical property, different mass, so all these having the same mass as well as same chemical property are the given elements in our world. All of the atoms of one element is similar in mass as well as similar in chemical property. Fourth postulate of Dalton's atomic theory. Atoms of different elements have different masses and chemical properties. As what you see in this picture, there are the green atoms and the purple color of atoms. You can see in here the 2 are different atoms of different elements. So this atom having different mass as well as the chemical property is also different. Fifth postulate of Dalton's atomic theory. Atoms of the same element can combine in more than one ratio to form 2 or more compounds. As you can see, this picture is an example of an water molecules. Here, in many compounds, the 2 atoms combine the whole number means 2 atoms of hydrogen and 1 atom of oxygen are present. In the second picture of the carbon dioxide, there are 1 carbon and 2 oxygen are present, because in his postulates it's said that there is no 1/4, 1/2 of atoms. It should be in a whole number. Sixth postulates of Dalton's atomic theory. The relative number and kinds of atoms are constant in a given compound. In 1 unit of water molecules, 2 hydrogen and 1 oxygen. As you can see in this picture, the red atoms is the oxygen and the white atoms represent the hydrogen. There are 2 hydrogen and water molecules and 1 oxygen. So in every molecules of water, same numbers of atoms are present, so the atoms are constant in any molecule compound. In the next picture, as you can see, the carbon dioxide. 1 unit of carbon dioxide is 1 carbon and 2 oxygen. Oxygen are always there, so the relative number of the kinds of atoms are constant in given compound, and the given compound is always constant.